Life's building blocks found in planet-forming disk. First time ever. Life's building blocks found in the cradle of planet formation. A game changer for astrobiology. Imagine a universe where the seeds of life are sown from the very beginning, embedded within the swirling disks of gas and dust that give birth to planets. This tantalizing prospect has just taken a significant leap forward, as scientists have made a groundbreaking discovery that challenges our current understanding of how life emerges in the cosmos. The breakthrough: complex organic molecules in a planet-forming disk. For the first time, researchers have tentatively detected complex organic molecules, essential building blocks for life, in a protoplanetary disk surrounding the young star V883 Orionis. These molecules, ethylene glycol and glycolonitrile, are closely linked to the formation of DNA and amino acids, the fundamental components of life as we know it. How did scientists stumble upon this finding? The discovery was made possible by a rare stellar outburst from V883 Orionis, which heated up the surrounding disk, evaporating frozen molecules and making them detectable by the powerful Atacama Large Millimeter Submillimeter Array ALMA telescope. The international research team, led by Abubakar Fadul, observed the system multiple times between late 2021 and late 2022, uncovering 21 distinct spectral features that serve as molecular fingerprints. Unraveling implications, a new paradigm for life's origins? This finding suggests that planets might inherit the raw ingredients for life directly from their cosmic nursery, rather than relying on later deliveries via asteroid impacts or other mechanisms. The discovery could reshape our understanding of how widespread life's chemical precursors might be, is potentially making the emergence of life less of a rare cosmic accident and more of a natural outcome of the chemical environment in which planets are born. But here's where it gets controversial. Does this discovery imply that life is more common in the universe than we previously thought? Or are these molecules merely a prerequisite for life, with many other factors still required for its emergence? We want to hear from you. Share your thoughts. Do these findings shift your perspective on the origins of life? Delving deeper, methodological results and limitations. The research team employed ALMA to observe the V883 Orionis star system across 6 sessions, focusing on radio frequencies between 348 to 366 GHz. Specialized software was used to identify molecular signatures. Results: tentative detections of ethylene glycol and glycolonitrile were made, with column densities of approximately 3.6 times 10 to the minus 16 molecules per square centimeter. The molecules were found at temperatures of at least 80 degrees Fahrenheit for ethylene glycol and minus 300 degrees Fahrenheit glycolonitrile. Limitations: the detections require confirmation through higher spectral resolution observations due to significant line blending at the current resolution. Publication details. Paper title: A Deep Search for Ethylene Glycol and Glycolonitrile in the V883 Orionis Protoplanetary Disk. Authors: Abubakar M. A. Fadul, Canber R. Schwartz, Tushar Suhasaria, Jenny K. Callahan, Jane Huang, and Merrill R. Van Hoff. Journal: The Astrophysical Journal Letters, Volume 988, Article L44, August 1st, 2025. Seeds of Life Assembled in Space. A stunning discovery by ALMA telescope, the cosmic cradle of life. Groundbreaking discovery suggests the building blocks of existence are assembled in space. Imagine the fundamental ingredients of life being crafted in the vast expanse of space, rather than on planetary surfaces. A revolutionary finding by astronomers using the Atacama Large Millimeter Submillimeter Array ALMA telescope has brought us closer to understanding the origins of life. In the protoplanetary disk of the young star V883 Orionis, complex organic molecules like ethylene glycol and glycolonitrile have been detected, sparking a new wave of excitement in the scientific community. But here's where it gets intriguing. This discovery not only strengthens the case for the extraterrestrial formation of life's chemical precursors, but also challenges the long-standing reset theory, which posits that molecular destruction occurs during star formation. So what does this mean for our quest to uncover the secrets of life's beginnings? Delving into the discovery, led by Abubakar Fadul of the Max Planck Institute for Astronomy. The research team has made a landmark detection of 17 different complex organic molecules, COMs, in the V883 Orionis disk. These COMs, including glycolonitrile and ethylene glycol, are pivotal in the formation of amino acids, sugars, and nucleobases, the very foundations of life. Challenging conventional wisdom. The reset theory, which suggests that complex molecules are destroyed during the turbulent transition from a protostar to a fully ignited young star, has been turned on its head. The presence of these molecules in the V883 Orionis disk indicates that complex chemistry can survive and even thrive during this period. The cosmic connection, the discovery of ethylene glycol in particular, supports the idea that complex molecules can form in various cosmic environments, from the icy surfaces of dust grains to the intense radiation zones of young stars. This finding has significant implications for our understanding of the transition from interstellar clouds to mature planetary systems, unraveling the mysteries of the cosmos. As we continue to explore the vast expanse of space, we may uncover even more secrets about the cosmic seeds of life. And this is the part most people miss. The potential for future discoveries is vast, with higher resolution data and observations across different regions of the electromagnetic spectrum, potentially revealing more complex molecules. The big question remains: do the building blocks of life originate in space, only to be assembled into living organisms on planetary surfaces? Share your thoughts. Do you think the discovery of complex organic molecules in space brings us closer to understanding the origins of life? Recent news from the debrief. Insert links with brief descriptions, as in the original content, but due to character limitations, only a few are included here. James Webb Space Telescope made a puzzling discovery on Jupiter's moon Europa. These scientists may have had an answer. A discovery unearthed at Stonehenge have been traced to a surprising source. Scientists are working to identify this unusual object spotted by ESO telescope. Stay curious, stay informed. Get all the latest stories from the debrief, with more breaking stories at the end of this week's newsletter. Subscribe now and join the conversation. Life's building blocks discovered in planet-forming disk. Amazing astronomy breakthrough. Exciting discoveries in the cosmos. Key molecules uncovered in planet-forming disks. Astronomers have made a groundbreaking discovery, identifying 17 distinct complex organic molecules surrounding the protostar V883 Orionis. Among these findings is the first tentative detection of ethylene glycol and glycolonitrile, which serve as essential precursors to vital building blocks of life, including the amino acids glycine and alanine, as well as the nucleobase adenine, a fundamental component of both DNA and RNA. While this discovery does not confirm the existence of life, it significantly supports the idea that the essential components for life could potentially form throughout the universe, given the right conditions. Complex organic molecules, often referred to as COMs, have been detected in various cosmic environments, including the massive molecular clouds that are the birthplaces of stars. However, the process of star formation is highly energetic, raising questions about whether these molecules can endure the intense conditions of the protostar phase and be integrated into the material that forms planets. The research team, led by Abubakar Fadul from the Max Planck Institute for Astronomy, utilized the Atacama Large Millimeter Array, ALMA, to investigate V883 Orionis and successfully identify these fascinating molecules. The team plans to gather higher resolution data to enhance their understanding of these findings, confirm the initial detections, and possibly uncover even more complex organic molecules. If these molecules can exist in such extreme environments and survive the star formation process, it would provide compelling evidence that they could eventually be incorporated into planets, creating conditions conducive to the emergence of life. Abubakar Fadul expressed his enthusiasm, stating, "Finding these molecules in such an environment is really exciting because this is the last stage after the star is formed, but before the planet is forming. If these molecules could exist in such an environment and survive during the star formation, it would really get us the strong hint that those molecules eventually could incorporate into planets and eventually could make a favorable environment for life to emerge in the future." To unravel the mystery of how life originated, it is crucial to understand where the fundamental molecules for life on Earth are formed. Previous discoveries have identified these precursors in interstellar space, within the tails of comets, and in samples from asteroids. This indicates that intriguing chemical processes are occurring in space. Yet we remain uncertain whether these molecules are repeatedly formed, or if they can endure the transformation that planetary systems undergo. Fadul noted, "We know that during star formation there is a harsh environment, so we don't know if those molecules really survive this harsh environment or form within the disk. Where the molecules formed is one of the fascinating questions that we're still trying to find an answer to." V883 Orionis is approximately 1/3 more massive than our Sun, but is significantly younger, at just 500,000 years old. By studying this and other protoplanetary disks to analyze their chemical makeup, we can gain insights into how we, along with all living beings on Earth, came into existence. The findings from this research are detailed in 3 papers published in the Astrophysical Journal Letters, the Astronomical Journal, and the Astrophysical Journal.